Mac OS, or Linux. There is some trickery under the covers, and we can talk about that if you really want to know later on. But at the end of the day, they're lightweight and they're generally faster than VMs to create, to launch, and to interact with. Now, there is one major difference, and you'll see this a lot in Docker's official documentation, and there's space separation and shared fate. So if we think about our traditional hypervisor VM scenario, we are running a type 1 hypervisor, whether that's something like vSphere or any other solution out there. We have this barrier of isolation. The only way that we can break that barrier of isolation is if there's some kind of exposed piece, like maybe DPDK, where we can access the network hardware. Maybe we have some direct level access to like the CPU flag, so we can do nested virtualization. That's the only way that we can break that level of isolation between the hypervisor and the VMs that run on top of it. If OSA fails in VMA, it does not affect B, C, or N. So we have that level of isolation and comfort when we're running VMs. That's why they're popular. We're running a full stack of OS. But when running a full stack OS, we have full stack OS baggages. We have updates. We have driver issues. We have compatibility. We have all those things that come with running a full-blown OS on a Type 1 hypervisor. If we look on the left, that's what a Docker operating environment looks like. We have our hardware. We have our operating system. Again, Mac, Linux, Windows. Yes, Windows. But then we can have socket access as we define it to the underlying OS, and we use those shared libraries from that OS to shrink our container sizes. I don't need to worry about a lot of the underlying binaries and libraries that make that container run, because I have that socket access directly to my operating system. So like in Linux, we have that direct access. In Mac, we're actually running a lightweight VM using HyperKit. And in Windows, we are using WSL2 or, heaven forbid, Hyper-V to run that same VM. Now, once we have that container runtime, we are running apps. Now, I will generally refer to a container running a single app. That's the way they were designed. They're microservices, so we're supposed to run one application, one Python file, one binary per application. Now, the problem can happen is if app A is compromised and we have the socket access down, we can actually compromise the entire host. So there's not a true level of firewall security, whatever you want to call it, between the underlying OS and those containers. So that is an issue, and I believe there was a big breach that happened. I can't remember what company, probably 2 or 3 years ago. They were running Kubernetes. They had containers. Something was compromised in that container. They got underlying access to the Kubernetes node, and then they went horizontal and were able to gather a lot of trade secrets and things like that because of that access not being completely firewalled off. So we do have that concern. We do have shared fate. If my underlying operating system on that host fails, everything's gone as well. But no separation, no problem. It's actually a good thing. So the shared kernel space creates, again, those quick instantiation times. And there's no Department of Redundancy department. I'm not installing all those binaries and packages over and over and over again when I run that container. So there's so much more room for activities on those hosts. I'm looking at images being maybe a gig, maybe a gig and a half, as opposed to 30, 40 gigs for a standard VM. So we're saving a lot of space there. Windows containers are actually a thing. And if you ever want to play Stump the Chump with maybe one of your application guys, Windows containers can run. The caveat being you must run them on a Windows system because of that shared library system. So if I run like IoT Core containers on a Windows system, it's leveraging the underlying DLLs for Windows and allowing that to exist. So for like .NET and some other stuff, we can run that in a Windows container on a Windows host. If you try to give me that Windows container and I run it on my Mac, it's going to fail because I don't have those underlying libraries that are needed from that container to run. So for this instance and this instance, only you Windows users can win because you have more portability than my Mac here. But I'm only giving you that one. So building containers. How many people have written a Docker file before? Okay, good level of hands. Another reason you should know Linux. So Docker files create an image from a set of predefined steps. Now you see the syntax highlighting there. Each of those yellow words in caps is a verb, or what I'm calling a verb. It's an action. Each of those yellow lines creates a layer of that image. The idea is, if we're doing a lot of similar steps together, nest them all together with a single verb and just use the double ampersand to create an and chain in bash. Because if I change something at the very top of my Docker file and then rebuild it, I have to rebuild the entire image for it to work. As opposed to something at the bottom, I have all those pre-compiled layers and I'm only changing something at the bottom. I save a lot of time when I do that compilation. So each of those verbs triggers an action. The action creates the layers and the layers create the image. So when you do a Docker pull, you may see like 7 or 8 lines that come underneath that, with each having a progress bar for downloading and then execution and layering together, or decompressing, whatever they call it. Those are each layers. And you can determine those layers from the Docker file. One thing that I will say is that in the early days of container images, everyone was using Alpine Linux. Unless you have a specific need to use Alpine, please don't. It comes with a lot of baggage. Yes, it's small. Yes, it's quick. But the APK system, the way that you have to chain together different dependencies, binaries that work in Ubuntu or Red Hat don't work in Alpine the same way. Unless you have a specific need, don't use Alpine, please. For everyone's sanity, don't do it. But you do have to use a lot of bash to make these work. So when everyone says that network engineers need to know Linux, but they don't really get real deep into the details, this is why. Or things like this are why. Bash scripting, you can learn Linux or whatever, that's great. Good bash scripting, so if you buy a book on like bash automation, bash scripting, is worth its weight in gold. Plus, you can impress your friends at the bar when you pull out massive one-liners for like sed and awk and all those other cool things. And yes, it's all just bash. It always will be. It always has been. Bash is like the language of the internet, and it's never going to go away. It's been around for like 25, 30 years, maybe longer than that, maybe 35. It's not going away, so just learn it. It will always be bash. So now that we have a little bit of a background, let's make containers work for us. Why would we let containers, even on our laptops, let alone why would we use them for actual productivity and work? How many folks have written in Python? How many folks have experienced the joy of having to manage different Python versions? How many people have had to manage different Python versions with different virtual environments for every Python version? How many people have lost hair from doing that? There's a big bald spot back here that you all can't see. Yes, there are tools like PyEnv. Yes, we can try to use things like virtual env wrapper and other things to make Python easy. But on top of that, then we have tools that are built in things like Python. Ansible. So we may need 3 versions of Ansible, and we may need to regression test all those Ansible versions against all the Python versions that we've been using. We now have like n degrees of like balding going on here. Because we can use containers in an ephemeral way, and we can map local directories on our laptops to those containers, we can build static images as we need them for different versions of Python or Node or Go or maybe Ansible, or even if we're doing something lightweight with Terraform. We can use those containers to work for us by pre-building them with the binaries that we need and leaving them on our laptop. Or if we have something like JFrog where we can push them to a repository locally on our own environment, you can share them amongst your friends. Or just sharing Docker files, who knows? Because we can isolate the system binaries from the userland binaries inside of those containers, we can actually solve a lot of those issues. And if we break something, how many people have broken Python before? Try to install over it, you rewrote a version, and all of a sudden, something in your system doesn't quite work right, and you just got to wipe it and start all over again. That no longer has to happen because it's on a container. We delete the container, we rebuild it, Bob's your uncle. And again, we have that portability, so we don't have to do those stupid human tricks around managing all these different Python versions and things like that. But we do have to do other stupid human tricks to try and manage our containers. But I don't see Joe Clark over here anywhere, which is good. Oh, don't have him come out because I do really stupid things with GNU Make, and he will probably yell at me. In my code repository, I have some ways to make that a little bit easier using GNU Make. Has everyone heard of a make file? All the people who've been around a while, yeah, GNU Make. We can do things with phony targets in GNU Make to basically run bash targets for us to make this process a little bit easier, and I'll show that in a little bit. So, our demo, if you want to scan this QR code, that'll take you to my GitHub repository. It does not have the slides yet because I wanted it to be a secret, but if you check back, I don't know, maybe later tonight, I'll have a PDF of these slides as well. But all the code is up there today with a README on how to use the files that I provided. So with that, 15 minutes, just about enough time. Slide over. All right, so in this directory, I have a couple of things. I have my make file and I've got some folders here. What I'm going to be demonstrating is I've got two different versions of Python, 3.7 and 3.10. I have two different versions of Ansible. Yes, I know they're old. I did this for a reason. We have 2.9 and 2.10. For those who don't know, there's a big difference between how 2.9 operates and 2.10 with Ansible. 2.9, all of the network modules were included as part of the Ansible core. 2.10, they separated that out and have to run collections. So I'm showing the difference between those two. Ansible 2.9 is running on Python 3.7. Ansible 2.10 is running on Python 3.10. So what I will demonstrate here is let's go into the Python 3.7 directory, or 3.10, do 3.7. And I have a Docker file. So let's just cat the Docker file. So this is something that I've pulled from the Python Docker Hub location. And I've really just made a small change to it. This is a very base level container. And we can start with the Python containers from Docker Hub that are published by the Python working group or organization, whatever they call themselves. And we can do some quick editing. You can see that there's real basic stuff. We're installing some different files. We're installing Python from source. And then we're setting some pip stuff. And then finally, at the very bottom, this is what I've done. I've changed the PS1 so we have a different shell. We can know what version or what Docker container we're in. I've made a directory called my code. We're running these containers as root. Yes, I know, bad security practice. Run with it with me. I've changed my work directory to that my code directory. And then Docker purists will probably yell at me for this, but I'm just running bash in that container. Every container has to start with a process. Normally that process is some kind of code. I would run a Python script, or I'd run build a Go binary and then execute it. In order to get an actual shell in a container, we have to ensure that bash is running in some way, shape, or form. Usually that's with an entry point shell. I'm just running natively with bash. So we can make that happen. Also, I have this version.py, which is going to run the code, I'll just show it for you, cat version.py. We're just printing out the current time and printing out the Python version that's running in that container. So you can see, old Rocky and Bullwinkle style, nothing up my sleeve. I'm not doing anything tricky on my system. So that's what we're going to do with the Python container. Now, what I'll do here is I will show you my make file. What I have done here, again, don't let anybody who's an old Linux hat look at this because this is gross. But I have an ability to set phony targets and then run make build Python 3.7, which will execute a Docker build command. So I'm building that container without having to memorize all that crazy syntax or have a bunch of shell scripts. Similarly, I can do make Python 3.7, and that will run the container right here where it says Docker run with that long string of things. Basically, I'm saying run it in an interactive mode, run it with privileges, give me colors in my terminal, set my current or map my current working directory or this directory to the my code folder so that version.py that we looked at earlier will be brought into that my code folder, and then run the pre-created Python 3.7 container that we just made earlier. So if we do a make, and this will happen much slower if you were to do it on your machine. I've already pre-built these, so we don't have to, make small talk while it's building. So let's make build Python 3.7. So that's executing the Docker build command. And because my internet is awesome, it's going to think about it. This is frustrating. Happened to me yesterday. Okay, I'm going to, or it's my laptop. There we go. I've got this pre-built. So Docker images. So I have that Python 3.7 pre-built. So we don't have to worry about having bad internet connectivity. I built it 3 weeks ago. I will do the make Python 3.7. This is going to run the container. You can see that I've been dropped into root at Python 3.7 under the my code folder. If we do an ls-l here, we can see I have the Docker file was created and the version.py. So again, no trickery going on there. And then if I can do a Python version here. You can see it's running 3.7.16. And if I do a Python version.py, we can see it's printing the current date and the version as well. So what I've done here is I've used that Docker file to create a Python container that is running a specific version of Python, in this case 3.7.16, and I can use it to execute code that I wish to run in that version. If I want to suspend the container or remove myself from the shell, I can do a Control P Q. That drops me back to my native shell on my laptop. And you can see if I do a Docker PS, that code is still running right there. I can do a Docker exec, and I should be able to go right into, let's see here, ring Meitner, inspiring Meitner. Oh, I'm sorry. That would be Docker. No, not Docker run. Oh, sorry, Docker attach to inspiring Meitner. I'm back in that container. So it hasn't stopped running. So if we have a long run code, we can do that. By running bash as the command at the bottom of the container, if I do an exit, it will kill the container or bring you back to your shell. And if I do a Docker PS, we can see that container is no longer running. So because of how I've started it, once I hit exit to kill the shell, it will kill that running process, that bin/bin/bash process, which is required to run the container. Once I kill that PID1, you'll see that a lot in Docker documentation, PID1. Once I kill the PID1 process, the container will stop. Let's see here. And I will just do the same thing. I'll do make Python 3.10 to show you that, again, we have that new Python container. If I do an ls-l, we still have a version.py, but if I were to run it, you can see that I'm now running 3.10.11. So I've been able to change versions just by changing containers. Okay, kind of gimmicky, but you can say I use pyenv, and I use pyenv as well. And just to show that there's no trickery, I'm running 3.9.7, so neither one of those versions is running locally on my machine right now. Okay, you can say I use pyenv to manage my Python virtual environment, or my Python versions. Not a big deal. Now, where it becomes tricky is with things like Ansible. So again, I've pre-made that container. I don't want to rely on the Docker Hub thing. So I will show Docker images that I have pre-built, the Ansible 2.9 and Ansible 2.10. Now, I'm hoping this works because internet's been great. I'm going to make Ansible 2.9. If we were to do a Python version here, I built it with 3.7.16. So just like I said, I'm using that 3.7.16 as my base image. And actually, I can do this. I can cat the Docker file. You can see here on my Ansible containers, I'm just saying, use that image that I've pre-created from that Python 3.7 container that I've pre-created already. It's all good. It has everything I need, but I need to do something else with it. So I've rerun the PS1 to give me Ansible 2.9 instead of that 3.7. I'm installing, I'm copying the requirements.txt file that's also in there. Which just includes Ansible 2.9.27 and all the requirements to make Ansible work. So copy that into my working directory, in this case, that root my code folder. Install the requirements from pip, and then install the Ansible netcom and the SSH communication thing for Ansible 2.9, and then go back in and change the work directory and then run bash. So we have the Python version. I'll do Ansible version. So you can see that it will match 2.9.27. And if I go into the Ansible folder, we have this inventory, a Ansible.cfg, and a 99test.yaml file. Without getting too much into it, we'll cat the inventory and show that we're just connecting to an NXOS device. Sorry, an iOS XE device. This the always-on iOS XE sandbox. And if I do an Ansible playbook, 99 YAML, and we'll do --v. Let's hope my internet works. We should be able to gather the iOS XE facts from that always-on sandbox using that container and be able to operate whatever I want to inside of that specific container using Ansible. Again, pinned to that specific version. So now I've solved a Python problem, and I have solved an Ansible problem. And you can take my word for it that the same thing will happen. So let's exit out of this container. We'll make Ansible 2.10. And we can see if we cat the Docker file, excuse me, we're pulling from Python 3.10. Again, same things happen, except for the fact that now, excuse me, now I'm installing the collections from Ansible Galaxy for Cisco iOS and NXOS, needlessly so, but if we go into the Ansible folder and look at the inventory, so we'll cat the inventory, we have an iOS XE sandbox and NXOS sandbox. And if we run Ansible, well, let's do Ansible version just to show that I'm not a liar here. We do have Ansible 2.10.17 running, again, separate container, separate Ansible version, and then do Ansible playbook 99test.yaml, and we'll make it verbose because I like the sound of my own voice. And we should also connect to the iOS XE sandbox and the NXOS sandbox, again, using a different version of Ansible, using the collections that we had to install as part of the Docker image. So that's a very brief demo about how we can use Docker containers to simplify the management process of different versions of Python, different versions of Ansible, different versions of whatever you choose, just by building them and storing them and having them in a makefile. So I will, scroll back to my, I'll leave that back up there if anyone didn't have a chance to view it. You can also reach out to me with issues on that repository as well. Please fill out your session surveys for this. I like to get some feedback about what's good, what's bad, and different. I would also be remiss for those of you who have not or don't have a sandbox or don't have a dev test environment in which to play with these tools. If you go around to the other side, right off of my 1230, on the left side of that is the CML booth. Right now, CML, you can get 15% off of a CML Personal or Personal Plus subscription for a year. If you go over there, talk to Justin, who's manning the booth, and get scanned, you can get 50% off of a year of CML. So if you're CML curious, I talked to that. You can use that as targets for all of your automation needs as well. So continue your education, please. We have lots of stuff in the Cisco Youth Theater. We've got lots of stuff going on in terms of breakouts. We're on the Certification Lounge, on-demand library. And with that, thank you so much for your attendance.